Hello student. Today let's see the second semester of SEP radiation chapter. In radiation chapter, we see the Planck's radiation law and derive Wein's displacement law from the Planck's radiation law and also Rayleigh-Jean's law, Wein's and also Stephen's law from the Planck's radiation. Let's see. So as we know that the energy distribution of Planck's radiation law can be given in the two way in the terms of the wavelength and also in terms of the frequency. This is the E lambda into d lambda, the energy distributions in a flat body is given by 8 by Sc by lambda by 5 d lambda to the power of Hc lambda kt minus 1. And in terms of the wave frequency, nu E lambda E nu equal to d nu 8 by h nu by c cube 1 by e to the power of h nu by kt minus 1 is the two different forms of Planck's radiation in terms of wavelength and also in terms of the frequency. Let's we derive the Wein's displacement law from the Planck's radiation law. In example, it will ask for derive Wein's displacement law from the Planck's displacement law. We know that the Planck's distribution in terms of the wavelength can be given by E lambda 8 by Sc lambda cube 1 d lambda by e to the power of Sc lambda kt minus 1. Let it be equation 1, and this equation is differentiate with respect to lambda. This is the 1 by lambda phi is the first term, 1 by e to the power of Sc lambda kt minus 1 is the second term. Let differentiate in the form of product, which can also be differentiate with respect to divisions. But quotient rules can also be applied. Here we consider here is the product rule. Let's see. Then differentiate with lambda is given 8 by s is the constant we taken outside. Second function into differentiation of first function into differentiation of second function. So it is in the form of 1 by lambda. It can be written as lambda minus 5. Here is the e to the power of plus 1 to the power of 1. It can be written as minus 1 e to the power exponential. Then we see this one. After differentiate 8 by c, second function remains same. 1 by lambda for differentiation is minus 5 by lambda 6 plus 1 by second first function into differentiation of second function. It is minus 1 by e to the power of Sc lambda kt whole square. But here the term is there, e to the power of Sc. Again you differentiate, e to the power of Sc remains same because differentiation of e to the power of x is equal to e to the power of Sc lambda kt. So same is here. And see, this is the 1 by lambda is also there with coefficient Sc lambda kt is lambda Sc kt into 1 minus lambda square. After simplification, we can take LC of this one, the term outside, and also lambda 6 can be taken outside. Then it's use the this term outside minus by Sc lambda kt to the power will be remain. But there is a condition for the maximum energy emission. Their differentiation is equal to 0. Then this put this value is equal to 0. Then this term is supposed to be cross multiplied equal to 0. That's equal to 0. Then this part only remains here. So then minus 5 Sc lambda kt to the power of Sc lambda kt is equal to 0. Other left terms are equal to 0. Then put this, let's say lambda kt is equal to x in this equation 3. We get minus pi xc lambda xc x minus 1 x into e to the power of x x minus 1 equal to 1. On simplify we can get this one. But as we know that lambda is less than because the v is displacement apply to the shorter wavelength. So that why shorter wavelength apply ಆಗುತ್ತೆ. So that's why lambda is less than SC lambda kt. So then SC equal to 5 lambda. Put this value there as equal to 0. Then lambda t equal to SC by k. Here SC by k is the constant. SC equal to constant. That is lambda t is equal to constant. This is the Weis displacement law. It states that the product of the wavelength corresponding to maximum energy and temperature is equal to constant. Hence the Weis displacement law. Hence we as we move further, how can we derive the Rayleigh-Jeans law from the Planck's law? As we know that the energy distributions for the Planck's law can be given in terms of the wavelength is given by this formula 8 by SC lambda 5 ED lambda into the power of SC lambda KT minus 1. Let it be equation 1. We know that Rayleigh-Jeans is applied for the only longer wavelength. So the wavelength lambda is greater than SC by KT. So e to the power of SC lambda KT is equal to 1 plus SC lambda KT. Then we just replace the e to the power of SC lambda KT equal to 1 plus SC by lambda KT in equation 1. Then we can get the 8 by SC lambda by lambda d lambda to the power of SC to the power of equate here. On simplification, we get 8 by KT d lambda to lambda. That's the this is the Rayleigh-Jeans law. This is the Rayleigh-Jeans law. Just we get it. 8 by KT by lambda or to d lambda, which is the Rayleigh-Jeans law. Let's see derive Stefen's law from the Planck's formula. Here, the Planck formula is taken here is in the form of a frequency, that is E lambda T lambda equal to 8 by h nu cube by c cube 1 by e to the power of h nu kt minus 1. This is, as we know that this is in terms of the frequency. For the energy, the total radiant is can be overall frequency. The total radiant energy ನೋಡಿದ್ರೆ whole overall the frequency ನೋಡಿದ್ದಾರೆ. Frequency ranges from 0 to infinity. That's the integration of this Planck's radiation law. ನೀವು integration ಮಾಡಿದ್ರೆ you will get write down as in form of E equal to E lambda T lambda. The formula of the frequency is this one, Planck's radiation law. ಅದಾಗ then substitution ಅನ್ನು ತೆಗೆದುಕೊಳ್ಳಿ. In substitution e to the power of h nu kt ಅನ್ನು x ಅಂತ ಹೇಳಿ. ಸೊ ದೆನ್ ನ್ಯೂ ಇಸ್ ಈಕ್ವಲ್ ಟು ಎಕ್ಸ್ ಕೆ ಟಿ ಬೈ ಎಚ್ ಅಂತ ಆಗುತ್ತೆ. ಅದನ್ನು ಡಿಫ್ರೆನ್ಷಿಯೇಟ್ ಮಾಡಿದರೆ ಡಿ ಈಕ್ವಲ್ ಕೆ ಟಿ ಎಕ್ಸ್ ಡಿ ಎಕ್ಸ್ ಬೈ ಎಚ್ ಅಂತ ಆಗುತ್ತೆ. ಅಂದರೆ ಡಿ ನ್ಯೂ ಪ್ಲೇಸ್ನಲ್ಲಿ ಈ ವ್ಯಾಲ್ಯೂ ಇಡಿ, ಡಿ ನ್ಯೂ ಪ್ಲೇಸ್ನಲ್ಲಿ ಈ ವ್ಯಾಲ್ಯೂವನ್ನು ಇಡಿ, ಎಚ್ ನ್ಯೂ ಕೆ ಟಿ ಅನ್ನುವಂಥ ಪ್ಲೇಸ್ನಲ್ಲಿ ಎಕ್ಸ್ ಅಂತ ಹೇಳಿ. ದೆನ್ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಿದಂಥ ಸಂದರ್ಭದಲ್ಲಿ ಫಾರ್ಮುಲಾ ಇ ಈಕ್ವಲ್ ಟು 8 ಬೈ ಕೆ 4 ಟಿ 4 ಸಿ ಕ್ಯೂಬ್ ಎಚ್ ಕ್ಯೂಬ್ 0 to x infinity x cube dx dx minus 1 ಅನ್ನುವಂಥದ್ದು ಆಗುತ್ತೆ. ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡುವಂತಹ ಸಂದರ್ಭದಲ್ಲಿ ಜಸ್ಟ್ ನೀವು ಸ್ಟ್ಯಾಂಡರ್ಡ್ ಇಂಟಗ್ರಲ್ ಇದೆ, ಇದು ಎಕ್ಸ್ ಕ್ಯೂಬ್ ಅನ್ನುವಂಥದ್ದು 0 to infinity ಎಕ್ಸ್ ಕ್ಯೂಬ್ ಏನಿದೆಯೋ ಅದರ ವ್ಯಾಲ್ಯೂ ಇಸ್ ಈಕ್ವಲ್ ಟು 5 to the power of 4 by 15 ಅಂತ ಆಗುತ್ತೆ. integration part ಅನ್ನೋದಾಗುತ್ತೆ just put this value ಇದನ್ನು integration ಮಾಡಬೇಕಾದ್ರೆ this is a standard integral the standard integral this value ಏನಿದೆಯಲ್ಲ is equal to pi to the power of 4 15 ಆಗುತ್ತೆ values ಅನ್ನು ಇಟ್ಟಾಗ e equal to 8 by k4 8 into pi to the power of 5 k4 t4 5 ಆಗುತ್ತೆ ಸೊ t4 ಒಂದು ಬಿಟ್ಟರೆ T4 ಉಳಿದವೆಲ್ಲವೂ ಸಹ ಕಾನ್ಸ್ಟೆಂಟ್ ದಟ್ ಕಾನ್ಸ್ಟೆಂಟ್ ಅನ್ನು ಎ ಅಂತ ತಿಳ್ಕೊಳ್ಳೋಣ ದಟ್ ಈಸ್ ಈಕ್ವಲ್ ಟು ದಿಸ್ ವ್ಯಾಲ್ಯೂ ಬಟ್ ಆ್ಯಕ್ಚುಲಿ ಸ್ಟೀಫನ್ಸ್ ಕಾನ್ಸ್ಟೆಂಟ್ ಅನ್ನುವಂಥದ್ದು ಬಂದಿರುವಂಥ ಕಾನ್ಸ್ಟೆಂಟ್ನ ಜೊತೆಗೆ C/4 ಮಾಡಿದರೆ ಅದು ಸ್ಟೀಫನ್ಸ್ ಕಾನ್ಸ್ಟೆಂಟಿಗೆ ಈಕ್ವಲ್ ಆಗುತ್ತೆ ದೆನ್ ಎ ಸಿಯನ್ನು C/4 ಇಂದ ಇದು ಮಾಡಿದಾಗ ಎ ಸಿಯನ್ನು C/4 ಸಿಗ್ಮಾ ಅಂತ ಹಾಕಿದರೆ ದೆನ್ ದ ವ್ಯಾಲ್ಯೂ ವಿಲ್ ಗೆಟ್ ದಿ ಈಕ್ವಲ್ ಟು ಸಿಗ್ಮಾ t the power of sigma is the Stefan constant. So, as we see in the Stefan's law, energy, radiant energy is directly proportional to the 4th power of the absolute temperature. This is called Stefan's constant. Okay, this is about the derivation of Wein's displacement law. Wein's displacement law and also Stefan's constant and Rayleigh Jean's law. Okay, thank you.